Okay. If 3 over 5w equals 4/3, what is the value of w? So for these, I like to write them without any middles, okay? And from here, I just cross multiply, or you can move the 5 diagonally across the equal sign. So it lands up to the top, and you can remove it from here. Then you can move the 3 downwards diagonally. It lands here, and remove it from here. I think that's a little easier than the cross multiply. You end up with 20 over 9. That's answer choice D. The average number of students per classroom at Central High School from 2000 to 2010 can be modeled by the following equation, where X represents the number of years since 2000 and Y represents the average number of students per classroom. Which of the following best describes the meaning of the number 0.56 in the equation? So we're looking at a linear function here, and linear functions are of the form y equals mx plus b, where m represents the slope and b represents the y-intercept. So the slope you could think of as how much you were changing, okay, it's a rate of change, and the y-intercept you could think of as your starting point. So in this case, we are looking at 0.56, which is exactly the slope. So we can interpret it as a rate of change, and the units for that rate of change are going to be the same as the units of y over the units of x. So the units of y is the average number of students per classroom. So that's students per classroom for the numerator. And then for the denominator change in x, we're going to have units of the number of years. Okay? So in this case, change in y over change in x would be the number of students per classroom per year. So it's how many students you're adding per classroom each year or subtracting each classroom per year. So let's read the choices. The total number of students at the school, no, because it's not the right units. The average number of students per classroom, no. That would be the starting point, which would be the y-intercept. The estimated increase in the average number of students per classroom each year. So students per classroom per year. That's exactly the units we're looking for. The estimated difference between the average number of students per classroom in 2010 and 2000. So this is just taking 2 random years. We want it for each year, so it's answer choice C. Nate walks 25 meters in 13.7 seconds. So this is how many meters per second. That's units for speed. If he walks at this same rate, which of the following is closest to the distance he'll walk in 4 minutes? So we have another unit of time here, but it's different from our original. So we can't right away do a proportion. Before we do, we have to do a conversion. So we want to know how many seconds this is. So 4 minutes, and then we have a conversion factor of 1 minute corresponds with 60 seconds. Okay, and so if we multiply 4 times 60, that'll give us 240, and the minutes will cancel out, so we'll be left with seconds. Okay, you could also do it via proportion. So 240 seconds is the time that we're dealing with. We'll put that down the bottom where the seconds go, and x will be how many meters that he could do. So at this point we can cross multiply, or we can just move this 240 diagonally across the equal sign, right? That's the better way. So then we just have to multiply. So let's use the calculator here. So we have 240 times 25, okay? And then we have to divide that by 13.7. Right? We get 437. So it's approximately 450 meters. Choice B. Okay. So we have a whole bunch of information here, and then we have some questions. Question 10. What is the weight in newtons of an object on Mercury with a mass of 90 kilograms? So we know that the mass is going to be 90 kilograms. And we know we are dealing with Mercury, and Mercury's number is 3.6. Okay. That's the acceleration due to gravity. So we also need a formula, and there's one here. So weight is equal to m times g, and g is the acceleration due to gravity. So these are values for g. Okay. So G is going to be equal to 3.6 on Mercury. So then we could plug in the mass of 90 and the G of 3.6, and that'll get us the weight, which is exactly what they're asking for. So we do 90 times 3.6, and we get 324. So that's answer choice D. An object on Earth has a weight of 150 newtons. So we know the weight is 150, and that's on Earth. So the number for Earth is 9.8. That is G is 9.8. So right away, using the formula, we know W and we know G, so we could actually figure out the mass. And chances are we're going to need that, so let's just go ahead and do that. Mass times 9.8. Then we divide, so 150 divided by 9.8. That gets us 15.3. So mass equals 15.3. Then the question is, which planet would have the same object, on which planet would the same object have an approximate weight of 170 newtons? So we want the weight to equal 170 newtons, and we want to know which planet. So effectively what they're asking for is what is G going to equal? Because we know now the mass is 15.3, and that's not going to change depending on which planet you're on, right? So we can use that number. So weight equals mg. So we have 170 equals 15.3 times g. And so we just have to divide by 15.3. So we find that g is equal to, so 170 divided by 15.3, and that equals 11.1. So which planet would that be? I think that would be Saturn. So that's choice B. Right. So the next question. If the function f has 5 distinct zeros, which of the following could represent the complete graph of f in the xy plane? Okay. Well, 5 zeros means that it crosses the x-axis 5 times. So let's see. 1, 2, 3, 4. So that's no good. 1, 2, 3, 4. That's no good. 1, 2, 3, 4, 5, 6. That's no good. 1, 2, 3, 4, 5. So choice D. The equation above gives the height in feet of a ball t seconds after it is thrown straight up with an initial speed of v feet per second from a height of k feet. Which of the following gives v in terms of h, t, and k? So here we want to solve for v. Solve for v. To do so, we have to get rid of everything that is attached to v, meaning on the same side of the equals sign. And we have to do it in a particular order. So technically, it's a reverse order of operations. Okay? So basically, the things that are closest to v are left to the end, and things that are further away can be done first. Okay, so for example, the first thing I would do is I would add 16t squared to both sides. So that would remove it from this side here. So 16t squared plus h, that's going to equal vt plus k. My next move is going to be to subtract k from both sides. So I get 16t squared plus h, right, minus k is equal to vt. And at this point, to get v by itself, I just need to divide by t. So there's actually two ways I could do this. I could divide this whole thing by t, or I could divide each term separately. So I want to just see which one they do. I think they do it all together, perhaps. Oh, okay. So they do some combination. So basically, what we have here is they are dividing by t here, and then once again for this combination here. So you're allowed to do that, right? As long as everything has a t underneath it, whether it's combined or not, is fine. So then the reason why they do that, right, is that now they can say, okay, t squared over t, that's just going to be a t in the numerator, right? 16t. And then they're going to have plus h minus k over t. Okay? Because, yes, the exponents would subtract. You have 2 copies of t on the top and 1 in the bottom. So now you have 1 left in the top. So that matches up with answer choice D.